Hello, assalamu alaikum everyone. My name is Aisha Khalid and welcome to my channel Mathematics by Aisha Khalid. So in today's video, we are going to discuss a new topic which is complex numbers. It is one of the most important topics of P3 9709 A-level mathematics. So this topic will be covered in 2 to 3, maybe 3 to 4 videos because it requires a lot of explanation. There are a lot of new concepts in this topic. All right. So now what are complex numbers? Where do they originate from? So if we get a negative number inside the square root, we say no real roots. And we stop, we don't do any further math. However, the complex numbers opens up this field of mathematics for us. And there is an assumption here which is under root minus 1 is equals to iota. Now, how do we work further on it? So let's suppose if you have something like under root minus 4 iota. Minus 4, sorry. So how do we write it? Can I write it as 4 into minus 1? Can we further break down into square root 4 into square root minus 1? What is square root 4? Square root 4 is 2, plus and a minus both. And under root minus 1 closes into iota. That's going to be my answer. Let's take another example. Minus 7. Under root 7 into minus 1 closes into root 7 into root minus 1. This is iota. That's going to be my answer. Now, so therefore what we can conclude is that a complex number is a combination of real and an imaginary number. So this is the real part, this is the imaginary part. So yes, complex number can have a real aspect to it and can also have an imaginary aspect to it. All right, now, different examples of complex numbers. 3 plus 4 iota, minus 2 minus 5 iota, 3 iota, 4, 7 plus 2 iota. So many different ways of writing a complex number. Yes, a complex number can only have a real part, which means the iota part is 0. Yes, a complex number can only have the imaginary part, meaning the real part is 0. Now, let's talk about addition and subtraction of complex numbers. Three plus 4 iota minus 5 minus plus 6 iota. Iota with the iota, 10 iota. 3 minus 5 minus 2. That's going to be my answer. Now, the first thing is that we have assumed that iota is equals to square root minus 1. Put a square on both the sides. So iota square is equals to minus 1. When do we use iota square? We use iota square when we have to multiply and divide complex numbers. How? 3 plus 2 iota, 5 minus iota. Multiply the brackets. 15 minus 3 iota, 10 iota, minus 2 iota square. 15 plus 7 iota, minus 2 into minus 1. Minus minus is a plus 2. 15 plus 2 is a 17 plus 7 iota. Alright, now, another new concept is let's understand what a conjugate of complex number is. So z is equals to 3 plus 2 iota. Z star means that we're talking about the conjugate. Now, what is the conjugate? The conjugate is change the sign of imaginary number. Meaning 3 minus 2 iota. It's fixed 3 minus 2 iota. P is equals to minus 1 minus 3 iota. So P star is going to be minus 1 plus 3 iota. Fixed. Okay, just change the sign of the imaginary number. Okay, that's called the conjugate of a complex number. When do we use conjugate number? When do we use the conjugate of a complex number? In division of complex numbers. So for example, it is 3 plus 2 iota divided by 1 minus 2 iota. So what's the next step? We multiply by the conjugate and we divide by the conjugate of the denominator. Multiply and divide by the conjugate of the denominator. How do we multiply? We multiply the numerator by the numerator. We multiply the denominator by the denominator. If you look at the denominator, it is a minus b, a plus b closes into a square minus b square. 3, 6 iota plus 2 iota plus 4 iota square. A square minus b square. 3 iota square is a minus 1. 6 plus 2 is 8 iota. 1 minus 2 iota square. 3 minus 4 is a minus 1. 1 minus 2 into minus 1. That's going to be my answer. All right. Let's do another example, because doing another example is very important. How do we divide this kind of a complex number where there is just a single denominator, which is imaginary number? Just multiply by 3i, just divide by 3i. We don't need a conjugate here. 4 into 3 is 12 iota, 3 iota square. 12 iota divided by iota square is a minus 1. 3 times 3, 3 times 4, so it becomes a minus 4 iota upon 3. The purpose of dividing a complex number is that we do not want a complex number or a complex number expression in the denominator. In the numerator is acceptable. Alright, so far we've done addition, subtraction of complex number, multiplication, division of complex number. We've understood how complex number look like. Now the next thing is putting the complex number on an Argand diagram. What is an Argand diagram? Argand diagram is representing the complex numbers on the axes. Now, this is the real axis, this is the imaginary axis. Label it 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Now, how do we, for example, the complex number is 2 plus 3 iota. If you want to write it in a coordinate form, it's 2, 3. 2, 3 is this. So, this is my complex number z. Let's do another complex number. P is equals to minus 1 minus 4 iota. So it becomes a minus 1 comma minus 4. Minus 1 comma minus 4 is this. This is going to be my complex number P. And this is exactly how we need to plot the complex number on an Argand diagram and join them with an origin. And since these are lines with magnitude, with a direction, so you can say complex numbers are vector quantities, because they have a direction and they also have a magnitude. I hope this concept is clear. So if you have a W complex number which is minus 5 minus 3 iota, it means it's minus 5 comma minus 3. Minus 5 comma minus 3 means this is where we stand. Let's join them with a line. This is my complex number W. Alright, now next thing is next very important thing is, what is modulus? Modulus is the magnitude of complex number. And the magnitude of complex number is represented by a modulus sign, which is if the complex number is AB, A plus B iota. So the magnitude is going to be A square plus B square. Alright, so let's find out the magnitude for these complex numbers. So Z magnitude is going to be square root 2 square plus 3 square. Becomes 4 plus 9, which is under root 13. What is the magnitude of complex number p? Is going to be 1 square plus 4 square. I'm not taking the minus sign because minus sign eventually cancels out when you square a negative number. So square root 17. Modulus w is square root minus 5 square plus minus 3 square. 25 plus 9 is under root 34. All right, now, so we've done the modulus concept as well. What is argument? Now, argument is a little tricky. Magnitude of the complex number, and remember, this magnitude is always from the origin. It means for the magnitude of z is this part. Magnitude of w is the length of this vector. Magnitude of p is the length of this vector. Now, moving on to the argument. Argument is the angle complex number makes with the positive x-axis. The positive x-axis is very important here. So if you talk about the arguments of these complex numbers, this is the argument, alpha. For this one, this is the argument. For w, this is the argument. So if I generalize and if I look at the complex numbers in all the 4 quadrants, this is my complex number in this one. This is my complex number in this one. This is my complex number here. And this is my complex number here. The argument for this is going to be alpha. The argument of this is going to be pi minus alpha. The argument over here is going to be minus alpha. And the argument on this region is going to be minus pi plus alpha. So if I quickly alpha, pi minus alpha, minus pi plus alpha. And this is how it looks like. This is how we take the argument if the complex number is if it's in the first quadrant, the second one, the third, or the fourth. Now let's do examples. So for example, the first argument is p3 plus 4 iota. Let's do a generalized version first. So z is equals to a plus b iota. How do we find out alpha? Alpha is the basic angle, which you also find out in the trigonometric topic, which is b upon a. Do not take signs of b and a to find alpha. We take b as positive and we also take a as positive to find out alpha, because this is a basic angle. Sometimes the basic angle itself is the argument. Sometimes you have to use the formulas that are given in each quadrant. Plotting the argument on an Argand diagram is very important to find the argument. Always plot complex number on the Argand diagram to find the argument. How do we go about it? 3, 4. This is how the complex number looks like. And this is the angle that we have to find out, which is alpha. So alpha is equals to tan inverse b upon a. And the argument has to be in radian mode. So it becomes tan inverse 4 upon 3 gives you 0.927. So you can say argument of z is equals to 0.927. Okay, let's do the argument of another question. This is example 1. Let's do example 2. Argument is minus 3 plus 5 iota. So minus 3 plus 5 iota. Minus 3 here and 5 here. This is the point. I'm doing a rough sketching now, okay? So I can clearly see that this is the argument, which is pi minus alpha. How do we find out alpha? And how do I know that it's pi minus alpha? Because it's in the second quadrant, and second quadrant formula is this. Finding out the alpha means tan inverse 5 upon 3. 1.03. So the argument is 2.11. Now, example 3. P is equals to minus 5 minus 7 iota. And I'll take another one simultaneously. Q is equals to 1 minus 3 iota. Let's plot both of them on this Argand diagram. minus 5 minus 7. So it is going to be this entire argument. So this entire argument is minus pi plus alpha. How do we find out alpha? Alpha is tan inverse 7 upon 5. We get 0.95. 0.95 minus pi plus 0.95 gives you minus 2.19 radians. Now the next is Q, which is 1 minus 3 iota. 1 here, minus 3 here. So roughly it will become, and this is going to be my argument, which is minus alpha. Let's find out alpha first. 3 upon 1, tan inverse 3, 1.25, make it negative. This is the argument of Q. This is the argument of P. Alright, so that's about it. Stay tuned, folks, for my next video where I'll be discussing advanced concepts of complex numbers. Take care. Allah Hafiz.